Good morning, good afternoon, good evening. This is Edgar Collado, and today I present my Machine Learning with Python project assignment. This project assignment was performed thanks to the video tutorials and support from Skyfi Labs team. And without further ado, let's begin. We installed the Anaconda software package, has various programs and development environments. I'm using a Jupyter notebook and I'm using Python with this notebook. It includes some example datasets. I'm using the Boston dataset. So let us see this. Boston house prices dataset. We have 13 attributes. Each has 506 observations or instances, and the median value is the 14th attribute, which is the target. So I'm not going through all of them, but we have the crime, per capita crime rate by town. We have the LSTAT, percent of lower status of the population present, the RM, average number of rooms per dwelling, and the DIS, weighted distances to 5 Boston employment centers. So I'll just scroll down. We have the data set viewed, some of them, parts of the algorithm. I just want to highlight the absolute correlations to the targets. Here we go. Absolute correlations to the targets, to the target value. Again, these are absolute values. We have all the 13 attributes. Important, the CHAS will not be considered as a dummy variable. But the important one, the highest correlation, LSTAT, RM, and so on, and the lowest is DIS. Taking into consideration the highest one, the LSTAT, the highest correlation, we proceed to do this training and testing. We do our manipulation of variables, mean, max scalar, normalization, mean square error for the loss function, cost function, etc. So keep on scrolling, and we get our graphs. This is an example of one of those graphs. So now we have our plot animation over here. We have our scatters, the linear regression that best fitted this data of LSTAT. We also have it here, the scatter plot in blue, and the training, the testing scatter in blue, and the training plot in the regression line we modeled. We have our errors, the iterations, how they minimize thanks to our machine learning algorithms. And we also have our targets, predicted targets, attribute, target, and predicted. Keep on having the scatter of the test data and the plot of the test data. Again a slope that goes downward. Again, this LSTAT is the highest correlation one, but if a negative is slope. Again, our y target and predicted y's. If we want to observe for the other attributes how they are correlating with the target, let's take the next one, RM. So we only have to change here the RM variable, and we just run it with with cell run all below. So everything is going to run, and we'll see the results in a bit. Okay, so now everything has run. Let us see our graphs. You see, we have a positive slope in the linear regression line. Okay, here is it statically. Here we can see it, the scatter of the test data versus the trained plot, linear regression plot. Okay, and in terms of errors, it is very, very stable. In the beginning, it has a slight downward curve, but it's pretty stable here. Okay, so again, okay, one important thing to note is the mean square error for this RM value the mean square error is 0.0164. Let's compare it to before. LSTAT 0.0211, 0.0164. So more or less there's a difference of 1.5. Okay, so it is greater the LSTAT error to the RM error. Okay, so let us continue. Next, we will take our DIS, less correlated attribute. Again, we just do DIS, and we just cell and run all below, and be patient with it. Okay, let us now see our results. We have a positive slope correlation, but it's very little. Again, we have the scatter of the test data with the trained data linear regression. The errors over here slowly start to normalize between the 50 and 100 iterations mark, and we keep on going, and we have a mean square error here that is also considerable. It's the greatest one, I think. Okay, the biggest one, yes, let's see. So we can compare them. That the smallest mean square error was the second attribute. The highest was the least correlated one. Okay, so we have that. We have our target that attribute with our target wise, and predicted wise there's some difference. You can consider there's a tendency of difference here. Okay, so again, scatter and plot of tested values, slow positive slope. Again, values here have slight difference. Okay, so that's it in a nutshell. Again, I want to thank Skyfi Labs support on this process and the use of machine learning, but with Python. I was familiar with MATLAB, but not with Python. I'm very grateful for this. And any doubts or questions, I'll be here. You can contact me. Okay, have a good afternoon, everybody, and good evening.